Okay, we're going to talk about implicit differentiation, which is topic 3.2. We're going to have some vocabulary here. We're going to talk about the difference between explicit and implicit. Okay, up to this point, we've only had equations that have been expressed explicitly. So explicitly for y. So basically the y is by itself. But now we need to take a look at implicit. Now, these aren't very easy to get y by itself, and some of them are impossible so to get y by itself. So these are implicit equations. So we need to learn how to do implicit differentiation. And it kind of goes along with the chain rule that we've already learned. So let's just go through a couple of these. Okay, let's go through all of them actually. So if I ask you to find the derivative of x to the third, now we're taking it with respect to x. That's what we've always been doing with the respect to x. So can you take the derivative of x cubed? Sure, that's the power rule. That's not the chain rule because our base is x. So that's just the power rule. 3x to the second. But let's look at b. Okay, this is not x to the third. This is u to the third. This is something other than x to the third. So it's kind of like the chain rule because this is not an x. So let's use our chain rule. We're going to take the derivative using our power rule is 3u to the second. Now again, I know that's a y, but that again, something other than x. So that's our derivative rule. But what's your correction factor? Well, again, over here, our correction factor is the derivative of x, which is just 1. That's why we don't use the chain rule for that. But on something other than x, we do the derivative rule, and then we multiply it by the derivative of our u. What is the derivative of y with respect to x? Well, that's just the derivative of y with respect to x. Okay, to make it easier, the derivative of y with respect to x, we can just call that y prime. The derivative of y is y prime. These two things mean the same thing. This is understood, y prime. It's understood that it's the derivative of y with respect to x, which we've used that before. Okay? So let's try this one. The derivative of x with respect to x. What's the derivative of x? 1 plus the derivative of y with respect to x. The derivative of y with respect to x. That's dy dx, or 1 plus y prime. Okay? Well, people say, well, where's the correction factor? Well, there isn't a correction factor here. You're taking the derivative of y with respect to x. You get dy dx. We didn't use any power rule. We didn't use any quotient rule or anything. The derivative of y with respect to x is dy dx. Okay? All right. How about the derivative of this? What do you notice? You should notice that this is a product. This is a product, so we have to use product rule. So the first times the derivative of the second. Go ahead and write down the derivative of y squared. What's the derivative of u squared. What's the derivative of something other than x squared? So that would be 2y to the first. That's the derivative rule for y squared. 2y to the first times u prime times y prime. So first times the derivative of the second plus the second times the derivative of the first. The derivative of x with respect to x is just 1. The derivative of y with respect to x is y prime, or dy dx. Okay? So that's your answer. And you can simplify. Okay, so why do we need to do implicit differentiation? Because they will be asking to find the derivative of this type of equation, which is an implicit equation. We cannot solve this for y. So we have to know how to take the derivative implicitly. Okay, so here are the steps. Differentiate both sides of the equation with respect to x. Both sides is the key, because a lot of people forget this side. That's a very common mistake. All right, so let's go ahead and try it. If you want to go ahead and pause your video, go ahead and practice taking the derivative implicitly. Okay, so the derivative of u cubed. Again, this is something other than x. So it's the derivative rule, 3y squared times the derivative of u, the derivative of y, plus 2y to the first, derivative rule, correction factor. How about the derivative of negative 5y? Well, again, that negative 5, we don't have to worry about that. That's just a coefficient. What is the derivative of y with respect to x? X dy dx. The derivative of y is y prime. Derivative of x squared is 2x. And then be careful, the derivative of negative 4 is 0. Do not forget that, because that'll mess everything up. So that's step 1. Step 2, collect all terms involving dy dx on the left side of the equation and move all the other terms to the right side of the equation. It really doesn't matter if it's right or left, but just move all of the y primes on one side, move everything else on the other side. Okay? So 3y squared y prime plus 2y y prime minus 5 y prime. Move the 2x over. Step 3, factor out your dy dx. So factor out your y prime. dy dx, y prime, same thing. Y prime is a lot easier to write. It's understood it's dy dx. So we have 3y squared plus 2y minus 5 equals 2x. And the last is to get y prime by itself, dividing both sides of the equation by the left-handed factor. Okay, so here we go. Y prime equals 2x divided by 3y squared plus 2y minus 5. And that is your derivative y prime. Now notice, our derivative, we have an explicit derivative. We have an explicit derivative. It's in terms of x and in terms of y. Okay. All right. Let's try this example. This one's pretty tough. Okay, this one is pretty tough. You don't get much harder than this. Okay, so it says find the slope of the graph at this point. Okay, so find the slope of the graph at this point means the slope of the tangent line. That's what that means, okay? So we need the first derivative. So let's go ahead and do this side here. Okay, let's do this side here. This actually has a double chain in it. So here we go. We're going to not worry about the 3. Okay, we're going to take the derivative of all of this. So think of this as a composite function. Okay, we're going to do the power rule. So we're going to do 2 times RU to the first power times the derivative of RU. So I'm going to write that down instead of doing it in my head. Times the derivative of our U. Okay, so again, this is a double chain right here. So we're practicing that again. So power rule, 2 times U to the first power times the derivative of U. Okay, and then I'm going to go to the other side. 100xy. How are we going to do the derivative of that? Well, that's 100 times x times y. We can't do the product of times a product. I mean, we can't do a product rule with 3 things, only 2 things. So if you remember, I recommended that you call this your first function and call this your second function. So why don't you pause the video and try to use the product rule with this as your first and this as your second. Okay, so it should be your first times the derivative of your second plus your second function times the derivative of the first. Oh, that's 100, not 10. Okay, so this side is done. We still haven't taken the derivative of our U, because I had to use the double chain rule, so I didn't finish this yet. This is done. So I'm just going to carry this down. Don't take the derivative of this again. We've already did that. We still have to do the derivative of our U. So again, pause the video and try to take the derivative of your U. Take the derivative of this. Okay, the derivative of x squared is 2x. The derivative of U squared is 2U, again, something other than x, we're going to call it U. So times the derivative of our U. And then over here, it's 100x y prime plus 100y. Now, we have a y prime here, we have a y prime here. I mean, it's pretty nasty, okay? So all of this needs to be in parentheses. You're multiplying by all of that. So to get y prime would be very, very difficult to get it by itself. But here's the good news. And if you recall me talking about derivatives before, when you're given an x value, well, in this case, because it's implicit, They have to give us an x value and they have to give us a y value. Okay? So don't simplify when they give you a point. Just plug it into the derivative and then simplify it. Okay? So 6 times x squared plus y squared. 2 times x plus 2 times y prime, which is what we're trying to find, equals 100 times x times y prime plus 100 times y. Now find y prime. Pause the video, use your algebra skills, and try to get y prime by itself. Okay, so this is 9 plus 1, which is 10, so that's 60. Times 6 plus 2y prime. And again, you can use parentheses. I don't know why I'm using brackets. 300 y prime plus 100. Okay, so that's 360 plus 120 y prime equals 300 y prime plus 100. I'm going to move these y primes over here. That's going to give me 180 y prime because I'm going to subtract 100 from both sides. I get 260, so y prime is 260 divided by 180, cancel the zeros, reduce 26 over 18, and that's 13 over 9. What did you just find? You found the slope of the graph. The slope of the tangent line at 3, 1. So let's go over here. There's 3, 1. You found the slope of that tangent line, about 13/9. Okay? So that had everything in it that we've learned over the past couple of days. Okay? It had double chain and implicit differentiation. So that was a very, very good challenging problem. Okay, let's do one that's a little bit easier. Again, I would stop the video now and see if you can do this by yourself. Find the derivative of this implicitly. This one is not as challenging. Okay, let's check your answer. The derivative of both sides is what you do first. So that's 2x plus 8y to the first times y prime equals 0. Again, we're taking the derivative with respect to x. So this is like chain rule. Derivative rule, correction factor. Because that's something other than x. Okay, so when we solve for y prime, we're going to subtract 2x, divide by 8y, and that reduces to negative x over 4y. So that's your first derivative. So now it says find the slope of the tangent line to the curve at this point. Well, isn't that just evaluating this? So here's notation similar to what we used before. Finding the derivative at this point. Well, it's not at x equals, it's at that point. So the notation is going to look like this. The derivative at this point. Well, the derivative is up here, so let's go ahead and plug in our point. We have our x is the square root of 2, and our y is -1 over the square root of 2. So pause the video, see if you can finish C. Oh, I missed a letter. It's A, B, and C. I don't even know my own alphabet. Okay, go ahead and see if you can finish B and C. Turn off your video. Okay, check your answer. Hopefully you turned off your video and tried it. This is a -4 over the square root of 2. So however you did it, you could multiply by the reciprocal, which is -2 over -4. You should get 1/2. Write the equation of the tangent line using point slope. Y minus your y value equals your slope times x minus your x value. That's the equation of the tangent line. No, you do not have to rationalize your denominators in calculus. That's the good thing. Okay, so what did you find here? Well, go to this point, square root of 2. That's just a little bit bigger than 1. So somewhere around here. Okay. You found the equation of the tangent line, because this graph is that right there. You found the equation of the tangent line to that point. So implicit differentiation is kind of like the chain rule. Instead of u, it's going to be a y. So derivative rule, correction factor is y prime. Okay, and that is all.